Hi, we're going to be going over the three things you do, reflecting, translating, and rotating. We're going to start with this shape here. As we went over in class, we talk a lot about how do you know where is it reflecting? So the first thing you ask yourself is, what is the question requiring us? So you're going to have three options, x-axis, y-axis, or y equals x. Again, the axis could sometimes shift and be a line that's dotted, a line like y equals x, y equals 1, or x equals 1. But for the most part, we're going to be talking about these three options. For this one, I would always say start here and go up. If it's over the x-axis, as it says in the question, then all you have to do is count up. Go to the x-axis underneath a coordinate and then just move it down 2. It went up 2. This one goes down 3 at 7, up 3. So you get new coordinates. Don't forget when you're done to label your new coordinates. That's reflecting over the x-axis, which is the same as the y-axis. The one that we should definitely mention is the x equals y. So when x equals y, it gives you one extra thing to consider, and it's this formula. So there is actually a formula when this happens in a way. So I want you to notice it. A is 0, 0, becomes 0, 0, A1. B is 2, 2, becomes 2, 2. Here's where the formula starts to kind of show some formula we can use. And this is the beginning for the formulas for the rest of today's lesson. We are going to have formulas from here on out, is what I'm saying. C is 7, negative 3. C1 is negative 3, 7. D is 5, negative 5. D1, or the new D, is negative 5, 5. So look at the form. Basically, what we're doing is just rearranging the order. And that does kind of coincide with the actual terminology, which is y equals x. This line going through here is y equals x. I also rephrased it as y equals 1 over 1x plus 0, but it's the same. So that's the first time you can start seeing patterns develop. The next thing that we go over is translation. So how do you slide things? Sliding things has its own format, and they usually use these little slash marks. Some books just do what looks like parentheses. I'm always going to give you examples. I'm going to try to always make sure they either have these little slash marks or they literally say what to do within the directions. The other way of doing a slide is actually asking yourself, what is this slide? So from D to D, what happened? It went to the left 5, so minus 5, and it went down 3, so minus 3. And notice the shape is the same. We have not changed the shape at all. It is still a diamond. All of these shapes pretty much keep their shape. There's not much to change. The last one of these three I told you are so important. I want you to memorize these formulas. The first formula is a 90-degree counterclockwise rotation. And if you look at the shape, it literally does move counterclockwise. So it's actually going this way. One thing I wanted to show you is how the formula works. So this formula actually works. It goes from being 6, 2 to being negative 2, 6. So you switch the numbers and then make that first number a negative. And that goes for all of them. Look at 2, 2 becomes, switch it to 2 again, but negative 2. And same thing with this one. This becomes negative 5, positive 4 for C prime. So the other formulas are, here are the formulas. 180 rotation is negative x, negative y. And 270 counter rotation, or 90 degrees clockwise rotation, is y, negative x. So only 55% of Norton got this question right on the MCAS. And this question it has a lot of everything we learned already. So it goes into depth and it explains the translation. It says on a coordinate plane, a single transformation will be performed on square RSTU. Select 3 transformations where the shape will stay the same. So let's think, if we slide up 3 to the right 8, did it change the shape or is the shape still congruent? So that counts. Rotation 270 degrees counterclockwise. Did it change the shape about the origin? No, it's still the same shape. The only other one we would say is dilation, which we will get to later in the week, but 1 is the one that will keep it the same. Dilation, smaller numbers give you bigger and bigger numbers give you smaller. It's all part of ratio. So we'll go over dilations this week, but stick to this one here. Here's the first example where you actually have encountered 90-degree rotation and a 180-degree rotation about not the origin, but 1, 1. So this one's asking you, what would happen if we drew a line right here and we reflected it? Would the shape go on top of itself? It actually is no. What if it goes up right here? It's a no. What if it's a 90-degree clockwise rotation? About 1-1, we would turn it here. No. The 180 degrees clockwise rotation would be the one that works the best because it would actually shift the shape back on top of itself.